Now our third practical is a LCD. There are number of LCDs are available in a market, but commonly used LCD is HD 44780, which is a 16 character, and there are two line LCD, that is 16 character per line, and in this fashion there are two line are there, and that's why it is called as 16 into 2 LCD. Now we will first discuss the pin description of LCD. There are 14 pins are related to LCD. First three pins are related to power supply. Next three pin, that is pin number 4 to pin number 6. These three pins are related to control signal. Next pin, that is pin number 7 to pin number 14, is the data pins to carry information from one device to other. Now one by one we will discuss this pin description because we want to use this pin in writing the code for LCD. First, the first three pins are related to power supply. First pin number is ground pin. We are applying ground signal to this. Then next pin is a VCC signal. We are applying plus 5 volt to this pin, that is VCC. Then third pin is VEE, that is a contrast setting. Now here we are just connecting potentiometer between ground and VCC, and we are wearing that potentiometer to adjust the contrast of LCD. In this fashion, by wearing potentiometer which is connected between VCC and ground, we are just adjusting the contrast as per our choice. In this fashion, these three pins are there for related to power supply. Next three pins are related to control the LCD. Now these pins are called as a control signal also. Now first pin is called as a RS, that is a register select. In each LCD there are two controller. One is a data controller and data register, and next one is a command register. You can choose any one of the register to send our information. Means for example, suppose our RS value is equal to 1, that time whatever information on data bus, that is D0 to D7, it is passed to the data register. When RS is equal to 0, whatever information on D0 to D7, that is passed on command register. In this fashion, as the status of RS, the data is passed to command register or data register. When it is 1, it is passed to the data register. When it is 0, it is passed to command register. In this fashion, information from this bit, that is D0 to D7, it is passed to either data register or command register as per the status of RS. Suppose RS is equal to 1, then data, and RS is equal to 0, command. Next one is next control pin is the RW, that is read or write. Okay, with the help of this pin we just declare which action we are performing, which action performed by the controller. For example, suppose RW is equal to 1, that time controller want to read something from the LCD. Okay, means controller action which action controller want, that is read action. Suppose RW is equal to 0, that time controller want to write something on LCD. Means your data is moving from controller to LCD because controller want to write into the LCD. Means RW bar is equal to 0. In this fashion, RW pin declare which action demanded by the controller. RW is equal to 1 means read action. RW is equal to 0 means write action. In this fashion, the flow of information get changed. Suppose your RW is equal to 1. That time you are performing which action? Read action. Means data is moving from coming from LCD to controller. And when RW is equal to 0, in that case which action you are performing? Writing action. In that case data is moving from controller to LCD, means writing into the LCD. Next pin is enable pin. Next pin is enable pin. Here when you are giving the information is latched, into either data register or command register. That is depends upon EN pin, that is enable pin. When you are applying here low to high pulse on this pin, that is negative going edge, moving from high to low, that is negative going edge, at that instant information get latched into either data register or command register, depends upon RS status. Okay, information is available on this pin, that is D0 to D7, that is latched into data register or command register as per RS, that we know. But at which instant it get latched, that is depends upon enable pin. When enable pin is moving from high to low, means negative going edge develop on this pin, that time information get latched from D0 data bus to data register or command register. Next pin is pin number 7 to pin number 14, that is the data pins. That is there are 8 data bits you are sending at a time from one device to other. Okay, and these pins is called as a data pins, which is carrying information. That information is either data or command. Okay, then next pin is pin number 15 is for LCD plus, and next pin is LCD minus, and this is two pins are for backlight of LCD. In this fashion, this is you are connecting here plus 5 volt, and for LED minus you are connecting zero ground to this particular pin for backlight of LCD. In this fashion, just give explanation of pin diagram of LCD. Now next point, we already discussed that in LCD there are two register. One is a command register and second one is a data register. Okay, now information is available on data pin, that is passed to command register when RS is equal to 0. Okay, and suppose RS is equal to 1, that time information passed into the data register. Okay, now which type of command you are providing to the LCD, that is the question. Now there is a one list, and through that list you can give any command as per your choice. For example, suppose you want to set the cursor at which location. For example, somebody want to set the cursor at the left corner, somebody want at a right corner, somebody want to display your letters in the middle of the LCD screen. Anywhere you can display as per your choice, and before that just declare the cursor position. In this fashion, one of the command is cursor position, then increment or decrement of the cursor. Okay, means you want to shift the, because suppose you want to display register. For example, this is the letter, this is what we want to display. Okay, suppose you are placing cursor at particular location. Suppose your cursor will remain here only at that particular location. Within that only you are displaying R, on that only you are displaying E, then G, I. Means at the same location you are displaying all the letters. But that we don't want. We want to display a whole word as now this register. Means my cursor must be shifted towards right every time. All of you agree for this? Means you want increment or decrement the cursor as per your choice. Similar way, suppose you want to display some message on the screen. For example, I want to display PCCOE ENTC. Okay, that message on a LCD screen. In that situation, suppose some previous information is there, or some messages are there, then you are adding new a message, that is PCCOE ENTC. Okay, that get overwrite. Okay, and previous is also visible and your new message is also visible, means it is some garbage values display on LCD screen. To avoid that, your first role is to clear the previous information. Means you must clear the LCD screen first, and then display whatever message you want to display. In this fashion, you are giving one of the command, that is clear the LCD screen. Then set the cursor at home. Anywhere you can, at home means it is coming to the left corner. Okay, means first row first column position. In this fashion, cursor at home, and here cursor position means you can choose any position as per your choice. For example, somebody don't want to start from this left corner, somebody want to write from this here, that time he will give first line, fifth column, eighth column, like that. Because there are how many columns are there? 16, because each line having how many character? 16 character. In this fashion you can place your word anywhere as per your choice, and according to that just give the command to the LCD. Then regarding read and write, you know that when it is giving the direction of the data flow, data information is moving from LCD to controller or controller to LCD. Suppose RW bar is equal to 0, means which action? Write action. Write action means data is moving from controller to LCD. Okay, means data write into LCD. And suppose RW bar is equal to 1, means LCD get read by the controller, means information is moving from LCD to controller. Okay, means you are performing read action. Next one is enable pin. Information is get latched into either data register or command register at which instant? When you are developing here high to low pulse on this particular pin, that is high to low pulse you are generating at that negative going age. At that instant information is get latched into respective register. Now there are two way of configuration of LCD, that is 4-bit configuration or 8-bit configuration. First we will discuss 8-bit configuration. Okay, now in 8-bit configuration, first 8-bit data is coming on this pin, that is D0 to D7. Okay, then you select proper control signal. Okay, that is control signal, that is nothing but RS, RW or enable, and then send data or command to LCD. Now this is the hardware connection. Here 8 data pins are there and 3 handshaking pins are shown here. First one is RS, second one is RW, and third one is enable, and 8 data pins, that is D0 to D7. Now now we want to write the code. Before that, first we will discuss command subroutine and data subroutine. Okay, now first you are giving various command to LCD, such as the screen the LCD, set the cursor position, then increment the cursor every time. Yes, in this fashion you are giving various command to LCD. Okay, every time you are not writing same thing again and again. Instead of that, we are just writing command subroutine. Subroutine is subprogram. Okay, and that program you are calling after every command. Okay, means clear the screen, then set cursor position, shift the cursor, like that. Means every command, instead of writing same thing again and again, we are just writing that sub part or sub program somewhere else, and that sub program or subroutine is called as a command subroutine. Okay, now you want to give the command. Okay, you want to give the command, means on data bus which type of information you are providing? It is data or command. Okay, means on data bus carrying the command. Then you are setting rs rs. What it is? It is 0, because our information is command. Then regarding write or read or write operation, you want to write into LCD, and that's why RW is equal to 0. And what about enable pin? You are generating high to low pulse on enable signal, means enable high, then delay, and then enable 0. In this fashion you are generating high to low pulse, initially high, delay, and then low. In this fashion you are just generating negative going age. At that instant information get latched into the command register. This is the subroutine for one of the subroutine, that is command subroutine. Now these are the various instruction. Okay, you can use that instruction. For example, 01 is for clear the screen. 02 is the, means you are just giving this code. 02 is nothing but return home, means your cursor will come to the first line first position. Then suppose you are giving the code, that is 04, that time shift cursor to left, means every, suppose you are placing cursor here, every time it is shifted towards left side. Increment the cursor, means every time your cursor shifted to the right side. Okay, then 05, shift display right, whole display get shifted, now shifted left. Now 08 means display on, cursor off. Both are off. 0A means display off and cursor on. 0C means display on, cursor off. Then 0E display on, cursor blinking. 0F same display on, cursor blinking. Means for this facility either you use 0E or 0F. Then 1014, in this fashion you are giving various command. Okay, then one more important command is 80. 80 means force your cursor to the first line. Okay, means suppose there you are already using two line LCD. Either you want to display your message on first line or second line, that is as per your choice. Suppose I want to display the message on first line, I will give command 80. 80 means first line is selected, first line first position is selected. Okay, suppose I want to display my word on first line fifth position, then I will write here 8 84, because first line first position 80, then 81, 82, 83, like that. Okay, means you can start anywhere as per your choice, according to just give the address. Okay, 85 means first line fourth position. Okay, because 80 is nothing but first line first position. Similar way, suppose I want to display this message on a second line, the address is C0. C0 is address for second line. Okay, C0 means second line first position, C1 means for second line second column. Okay, in this fashion you are shifted towards right side. And one more important command is 38. 38 is nothing but we in the market there is a one line LCD, two line LCD, four line LCD are available. Okay, out of that which LCD you are configuring to the controller, that you must declare. Okay, in our practical we are using two line LCD. Okay, two lines 16 characters. Okay, and each character having 5 by 7 matrix. Okay, in this fashion there are two lines on. I'm just choosing the LCD which having two lines, and each line having how many characters, 16 characters, and each character having 5 by 7 matrix. Okay, and for that I'm just giving command 38, means I am just declaring to controller that I am referring to two line LCD. In this fashion, for 28 means one line LCD. In this fashion, for each type of LCD, there is a different command. Just refer that in your code. Okay. Now we are using two line LCD, and that's why we are giving command 38. Now this is command subroutine is over. Now one more subroutine we are providing, that is data subroutine. Okay, now different messages you are displaying on the screen. For example, TEB division, that message you want to display. Sometime you want to display ENTC department. Okay, ENTC department on first line and PCCOA on second line. Whatever message you want to display, you can pass into the data register. Okay, and for that information is coming on a data bus. Then this is the data, and that's why what is the value of RS is equal to 1, because now it is a data. Then what regarding read and write action, which action you are performing, writing action, and that's why RW is equal to 0. Regarding enable pin, that is it must be generating negative going age, and that's why enable is equal to 1 first, then delay, and then low. In this fashion you are generating high to low pulse, that is negative going age. This is according to that we are just writing the data subroutine. Now, based on this knowledge, my problem statement is I want to display my name on the LCD screen. That is my problem statement. Okay. Now, according to that, I will just give the explanation. Now, I'm already declared that there are three control pin. One is RW, RS and enable. As per my hardware connection, I will just declare which pin I am using as a RW, which pin I am using as a RS, and which pin I am using as a enable in my configuration.